ස්විට්සර්ලන්තයේ පැවැත්වුණු විද්‍යා ජනමාධ්‍යවේදීන්ගේ සම්මේලනයේ තවත් වැදගත් චාරිකාවක් සඳහා සහභාගී වෙන්න අවස්ථාව දැන් අපිට හම්බ වෙලා තියෙනවා. දැන් අපි ඇවිල්ලා ඉන්නේ ජර්මනියේ කොලොන් නගරයේ ආශ්‍රිතව පිටලා තියෙන යුරෝපියානු ගගනගාමී පුහුණු කරන ආයතනයට. ඒ ආයතනයේ පිටලා තියෙන Hayabusa සහ Mascot කියන ග්‍රහක ගවේෂණය කරන සහ ඒ ව්‍යාපෘතිය ආශ්‍රිතව වැඩ කටයුතු සිද්ධ වෙන ප්‍රධාන විද්‍යාගාරයට තමයි අපි දැන් පිවිසෙන්න සූදානම් වෙලා ඉන්නේ. ඉතින් ගිහින් බලමු ඇතුළට මේ විද්‍යාගාරය ඇතුලේ මොන වගේ දේවල්ද සිද්ධ වෙන්නේ කියලා. ලෝකේ රටවල් ගොඩක් නියෝජනය කරන ජනමාධ්‍යවේදීන් ගොඩ දෙනෙක් අද මේ අවස්ථාවට සහභාගී වෙනවා අපිත් එක්කලා. ඉතින් දැන් අපි ඔක්කොම එකතු වෙලා යන්නේ මේ විද්‍යාගාරය ඇතුළට. බලමු ඇතුළට ගිහිල්ලා මේක ඇතුලේ මොනවද සිද්ධ වෙන්නේ කියලා.
Wow. That's right. Okay. Anything happening this morning? Okay. Take the one. Yeah. Stefan, can we leave the luggage somewhere?
Yeah, sure. I will recommend somewhere in the area.
Maybe.
Or do you want to look
Maybe.
We can look. How long do you want to keep it there? Because the meeting room.
ග්‍රහක ගවේෂණය පිළිබඳව කතා කරද්දී යුරෝපියානු අවකාශ ආයතන එහෙම නැත්නම් යුරෝපියන් ස්පේස් ඒජන්සි මේ ආයතන හරහා විශේෂ ව්‍යාපෘතීන් කීපයක් ප්‍රයත්න කරනවා. එතකොට මෙතන ඔයගොල්ලෝ දකින්නේ ග්‍රහකයක් මතට ගොඩ බස්වන්න හදලා තියෙන මැස්කොට් කියන උපකරණය. තවත් ඒ වගේ උපකරණ ගොඩක් මෙතන ඔයගොල්ලන්ට දකින්න පුළුවන්.
Gravity User Support Center, and this is the place where traditionally we are operating instruments and traps for human exploration. So that was for space lab missions and also the Mir station, and now it's of course for Columbus, where we have an example of the cut from the Columbus station. But I will not say much about human explorations or astronauts. I'm sure you go to the Astronauts Center later on and you will learn a lot more about this. There is another aspect we were dealing with here and are dealing with here, and that's the robotic exploration of bodies in the solar system. And maybe we come first to this here, where you see a model of the Philae lander, the Rosetta lander, which was part of the ESA Rosetta mission to comet Churyumov-Gerasimenko and landed on this comet in 2014 in November. The Philae lander was operated from here, from the lander control center, but this was also developed and designed and to a large extent also integrated and built here in Moscow. The model, I don't even know the exact scale, but the real one is about a meter in size, 100 kilo in mass, and was brought by the main spacecraft to the comet. Here you see a model of the complete Rosetta ESA spacecraft with the lander in scale. Big spacecraft, 32 meters from one side to the other. But maybe first a few words why we were doing this, why we were going to a comet, why a comet is so interesting. Now we believe that comets are leftovers from the time of the formation of the solar system. So about 4.6 billion years ago, that's known pretty well, our solar system formed out of a cloud of dust and gas, interstellar cloud. Then very quickly they built a so-called protoplanetary disk. We can observe with telescopes similar disks like our solar system looked like 4.5 billion years ago. It builds a disk because there is some momentum in it, so like the rings of Saturn, of this type. And then fairly quickly means in about a few tens of millions of years, the big bodies build up gravitationally. That's of course the sun in the center, but also the planets further out. And smaller pieces of junk are leftovers. They're usually further away from the center, further away from the sun, and smaller bodies are in the range of from dust grains to a few tens of kilometers. And occasionally one of these smaller bodies comes to the inner solar system. That can be because of a resonance with a big planet, Neptune or Jupiter, or because the whole solar system gets turbulent, some perturbation with another star. So these pieces of junk come to the inner solar system. It gets heated up in the sun. The volatiles start to outgas. That's mainly water ice, but also carbon dioxide, CO. And the gas drags with it along the dust grains, and you have the phenomenon of a comet, a tailed star. Now, if we investigate such a comet and measure the composition, we get really the pristine, the original material from where the whole solar system, including the Earth and the Moon, were formed. And if we compare this with the composition as we know it for Earth, or with some examples from the Moon, of course, meteorites, then we hoped, and this was partly true, no question arose, to better understand the history of the solar system of the last 4.5 billion years. It's also the reason for the name, Rosetta. I'm sure you're all aware of the famous stone of Rosetta, which was found in Rashid, so Rosetta in Latin form in Egypt. And that's a stone now in the British Museum with a pretty boring, by the way, inscription in Egyptian hieroglyphs, in Demotic, and also in Greek. And this became the key element for our understanding of the Egyptian history, because Champollion, with the help of this trilingual text, could decipher the hieroglyphs at the end. And the idea was that Rosetta, in a similar way, would become the key to our understanding of the history of the Egyptian culture of the solar system. With the orbital mass spectrometer, glycine, which is the simplest one, but that's an indication that also more complex ones could well be.
So in 2,000 years, perhaps, space archaeologists can go to this comet and see these odd artifacts for human beings. I mean,
it was even planned earlier, because NASA had in its last round of New Frontiers mission, one mission studied, it was not selected at the end, CESA it was called, to go back to Churyumov-Gerasimenko, but not like Rosetta, investigated from remote with cameras and spectrometers, etc., but to go there and bring samples back to Earth. And they would have chosen exactly our comet for reasons one could question. The reasons were we know this comet and it's easier already before you launch to land selection and so on. And it was planned to bring material to Earth, where of course you have much better possibilities to do the analysis and to define minor components. Okay. So, that about the comets. A bit more words maybe about the mission itself. Rosetta, as I indicated, is an ESA mission, European Space Agency. It's in the science program, one of the four instruments, and this one was delivered in October last year to asteroid Ryugu. Now this is not a comet, it's a primitive asteroid, and analyzing comets, which, as I told you, are the leftovers from the very early phase of the solar system, and compare those with asteroids, which are a bit younger, also helps us to get the steps in between the very beginning of the solar system and what we know now from Earth or the Moon. Now, generally, for asteroids, there's very many classes. If you look at scientific publications, sometimes maybe confusing, but in principle, there is 3 big groups of asteroids. There is the so-called C-types, chondritic, and these are from main bodies which have not been separated yet. So it's really a mixture of what was in this protoplanetary ground. It's C because it's chondritic, so everything is mixed together. And then you have S, stone, and metal types. When the first planets formed, or protoplanets, which were partly smashed again and broken into small pieces, the material started to separate, like for the Earth. So you have